All right, question 1. It says circle the best choice. Again, we've had this on every exam where we have 5 of these questions worth 2 points each. Question A, which of the following molecules has an electrophilic carbon that will react with 2 equivalents of phenolithium? So we're looking at this nucleophile. We know that phenolithium is a very strong nucleophile. We know that it reacts with ketones. Let's look at these products that we have. Here we've got one ketone. We know that this will react one time. It will form an alcohol. Same with this one. One time it'll form an alcohol. Here we have an aldehyde. This will also react once to form an alcohol. Here we have an acetal. We know that these do not react with phenolithium. And then here we have an ester. We know that once it happens once we react with phenolithium, once we're going to get our corresponding ketone, like this. And then we're going to react one more time with phenolithium to get an alcohol. 2 phenyl rings. So this answer is going to be the last one. I shouldn't have circled those. Circling the carbonyl. So here is our answer. Let's go to B. Identify the molecule that contains no functional groups likely to be reduced by sodium borohydride. Part of this question is in chapter 23. So this is in chapter 23, this reduction of an imine with sodium borohydride. So you don't know that yet, but I'm just going to tell you it can happen. It will get reduced to the corresponding amine. So that means this one can. We know ketones can. We know that both of those can. We know aldehydes can be reduced. But nitro groups, you would have to use palladium carbon, very harsh palladium on carbon conditions to do this. So, which I'm not sure if we covered that either. I think that's also in chapter 23. So anyway, question B, like I said in the notes already, this is not a fair game question. That's some of that's from chapter 23. Let's look at C. Identify the molecule with the most reactive carbonyl containing functional group. This one a lot of people got wrong on the quiz, so I think it's worthwhile that we go over this. Let's list these in order. The first one would be an acid chloride. Second in order would be an anhydride. What do you think the third in order is? It would be an aldehyde. We don't have it listed here, but if there was a ketone listed, that would be fourth. What's next? 5 would be our carboxylic acid. If we had an ester drawn, these are equivalent. They're very similar. They're about the same. And so then this one would be 6, or amide. And that's because of the nitrogen is a little less electronegative than an oxygen, so it can donate into this to form a nice resonance structure here. And this makes this carbonyl less reactive. So identify the molecule with the most reactive carbonyl containing compound. That would be our acid chloride. Let's go to D. Identify the keto molecule that will have the highest equilibrium concentration in its enol form. Remember, we've got our keto enol tautomerization. And so what's really driving this is if this double bond is favored to form, right? And one way that we could do this is by having it stabilized in resonance. So for example, if we were to draw each of the enols for these, this is stabilized by this carbonyl that's it's this 1,3 dicarbonyl. This would be more favored than, say, either of these 2 carbonyls, okay? We're looking at the highest equilibrium concentration in its enol form. So the 2 on the right are not providing any additional support of wanting that enol form. The 1,3-dicarbonyl is better. And here we have an alpha-beta unsaturated carbonyl, where this would provide some additional stability. of the enol form, but this one in particular, what would this one look like? This one's kind of neat. The enol form of this guy would actually be phenol. And we know that this is very stable. It's aromatic. So if you can make an aromatic ring with this enol form, that would be very stable. So here, identify the highest. It would be this one. Identify the molecule with the lowest pKa. All right, lowest pKa we know is the most acidic, right? Most acidic. Okay, so when we look at these compounds, right away we want to look at alpha hydrogens because we've got these carbonyl containing compounds. So I'm just going to, in purple, I'm just going to circle where there are alpha hydrogens. There's some here and here, here and here. There are none on this compound and there are none on this compound. We have no acidic protons on these either, like an OH or an NH or something. That would be considered slightly acidic. So we're going to write an X on these. So these don't have any protons that would be acidic compared to these that are alpha to these carbonyls. So let's look at this. So we know that we have the pKa alpha to a ketone is around 20. And so we would say this is around 20. This one's also around 20. But here we have this alpha, this 1,3-dicarbonyl. This thing's going to be closer to, say, 9, pK of around 9. So the answer here is this dicarbonyl. Again, we're looking at acidic protons. And when I saw the list of molecules, I saw they all had carbonyl compounds. So we know that alpha hydrogens, and when I say alpha, it's the carbon right next to the carbonyl. These hydrogens are somewhat acidic. I don't know how to get rid of this. Okay, well, we're just going to deal with that. They're somewhat acidic, and so those were the CH bonds that we were looking at, and the dicarbonyl does win out on this. So that's question 1.